This is 5.2, solving a system. This one specifically is a linear and a quadratic function at one time. Notice they've given you a linear function, just a horizontal line, and they've given you a quadratic. And what they want you to tell them, sketch three graphs of a line and a parabola. So the first one we're going to do where they intersect in one point. So I'm going to take this line and this parabola, put it on one graph, and they need to intersect at one point. So notice this one's kind of like at 0, 2, and then it's just right there for a vertex, and it's right about here. So I'm just going to draw that parabola. Again, it's a sketch, so it doesn't have to be exact. There's the parabola, and I'm supposed to draw a line to where it intersects in only one point. Well, as long as it hits just the vertex, it's only going to hit one time. If I draw it any higher up, it's going to hit twice. So there's my parabola and my line hitting once. So they can intersect at one point. The next one they want me to draw is where they intersect in 2 points. So again, my parabola is going to be here. And I need it to intersect in 2 points. So I have a lot of options this time. I can draw my line here for twice, or up here. I could really draw it anywhere headed up. So notice I'm going to intersect 2 times. So this is my 2 points. And then last but not least, they want me to draw where they won't intersect at all. So my parabola is going to go right here. And in order for it to not intersect at all, it has to be below the parabola. So this is a no solution. There is no point that they share in common. Here they share 2 points in common, and here they only share 1 point in common. So a constant linear function and a quadratic function can intersect at 1, 2, or no points. No solution when they don't intersect. I've got 2 solutions, and I have 1 solution. So this lesson, that's what we're going to be investigating specifically. We're going to turn to page 256, and we're going to ignore the first problem that they gave us because it's kind of a mess. Your book didn't do a great job of this, so what you need to know is that you, in order to put them in the graphing calculator, which is what we want to do so we can look at the picture, in order to do that, we've got to have them into y equals. This one is my parabola. It's squared, so I know it's a quadratic, makes a parabola. I can go ahead and alpha y equals and type in my 1/2 x minus 3 squared. So there's my equation. This one's not ready for the calculator, so I have to move the 3x over. So I'm going to have y equals negative 3x plus 4.5. So I had to move the 3x over. It becomes negative 3x plus 4.5. Now I can go ahead and graph it because I first need to decide, does it have 1 point, 2 points, or none in common. So I'm looking for the line. There it is. Now it looks like, we know it's not no solution. It looks like it hits right here, but I'm not sure about the other places. And in the table it will show me, but definitely it's around x is negative 1, 0, or 1, somewhere kind of in there. So I'm going to go to the table. So if you notice when x is 3, they do not share the same y value. y1 and y2 do not match. So I'm going to go up to 2, they don't match. I'm going to go up to 1, still they don't match at 1. At 0, I can't tell if they match or not. One's a fraction, one's not. So let me go back to y1. Okay, this one's a decimal, so let's change this. Let's delete that and put 0.5. Okay, so get 0.5 in there instead. Since we did 4.5, we're going to go with 0.5. That will help us in the table. So when we go back, at 0, notice that my y values are the same. So I know that this is a point of intersection, 0, 4.5. And I'm going to double check at negative 1 if that's a point of intersection. And notice it is not. 8 and 7.5 don't work. Again, not there, and I don't see them coming together. This guy's getting larger in the y column, and this guy's getting larger as well, but they're not getting closer together. You can check the next one. You see that 32 and 19.5 are very far apart. So I have 1 point. If I look back at the graph, sorry, it's regraphing because I changed it to a decimal, but if I regraph it, I only see, for sure I know that point right there, that's 0, 4.5. That's the point of intersection. So I have finished this problem. I found the point that the parabola and the line share in common. That's my goal. I need a point or 2 points, or maybe no points. So on the next page, 257, notice this one's not in y equals, so I'm going to move the 3x over. So I got negative 3x when I move it to the other side. If you want, feel free to put plus 0. It's not necessary. This one also has to become y equals, so I'm going to add 6. But those are not like terms, so I'm not going to add them together. So I've got negative 3x squared plus 6. They've both got to be in slope-intercept form to put them in the calculator. So I'm going to type in negative 3x. I don't need to put plus 0. And I'm going to do negative 3x squared plus 6. Your calculator is going to graph both to show you how many points that you share in common. I can clearly tell that I'm hitting once, twice. That means I share this point and this point in common. For the line and the parabola, they share this point and this point over here. This point is in the negative x values. This point is in the positive x values. So I'm going to go to the table and I'm going to look in the negative x values. Those are not alike. Those are not alike. See if that's a little bit better. When I go down to negative 3, they don't match. Negative 2, that's close. That is not a match. 6 and negative 6 are not a match. Negative 1, that is a match. Negative 1, 3. So I'm going to come right here and I'm going to write down negative 1, 3. That is a point that they share in common. Now, remember, I'm going to go back to the graph. Okay, I got negative 1, 3. But I have to find this point over here, and it looks like it's around 2 for x. So, sorry, back in the table, at 0 it's not a match, at 1 it's not a match. Again, this is not a match. 3 and negative 3 are not the same. At 2, I do have a match. So at 2, I've got negative 6 for both y values. So they share 2 points in common. Notice that I share negative 1, 3, and I share 2, negative 6. Those are the 2 points they have in common. So I'm ready to do in the next problem. I'm going to take out what I have in there. My first is not set to 0, so I'm going to subtract 1. So I really have y equals 1/2, or you can say 0.5. Make sure the minus 1 comes over. The second one, you're going to subtract x, but this is important. This is a negative y, so I've got negative y is negative x plus 6. But I'm not finished. I may not leave y negative, so I make this negative 1. I use the negative 1 there, and I divide it out, so I've got y equals, that's going to be positive x and negative 6. This is going into my calculator along with that. So I got x minus 6 going in, and then if you want decimals, you can do 0.5. If you'd prefer fractions, you can do the 1/2. It's going to be up to you. I think decimals are a little easier to read when I'm graphing. But notice I've typed it in, I moved the 1 over, negative 1. When I graph it, there's my line. There's my quadratic. Oh, they don't touch at all. So what we're looking for is points they share in common. They don't have any points in common. These are two separate graphs. So what I would have to write down is no solution. They don't share anything in common at all. And then we're going to go over to page 258. Now your book has all this crazy math. I'm not worried about that. We're still graphing. As long as it's in y equals, we can graph it. So my first equation, figure that out. Okay, my first equation says 1/4. Again, you can use the decimal or you can go with the fraction. 1/4 is probably better as a fraction. Totally up to you. You can put 0.25. So I've got that guy in the calculator. I need to put this guy in, but I have to get him ready for the calculator first. So I'm going to subtract 3x. That means I've got negative 2y is equal to negative 3x plus 13. And then I'm going to divide everybody by negative 2. So I'm going to get y equals negative is a positive 3 over 2x. You can go with the decimal. I'm just going to keep the fraction. And I'm going to say minus 13 over 2 because that's going to stay negative. And I'm going to type it in because my calculator is wonderful at fractions. So I'm going to go alpha y equals, I'm going to say 3 over 2x minus, I'm going to do alpha y equals 13 over 2 because that's my second fraction. And I'm going to go ahead and hit graph. Again, I want to see what the picture looks like before I decide if I have any points in common. When I look, there's my line. I don't know why this is graphing so slowly. And here's my parabola. Okay, I'm not sure. I know it hits 1, 2, 3, 4, 5, 6, somewhere around 5, 6, 7, 8, somewhere in there. But I don't know how many times, so I'm going to go to the table. I have to get the exact point anyways. We said it definitely wasn't the negatives. So at 3 I can tell those are not the same y values. At 4 I do not have the same y values. At 5 I do, so I know one of my solutions is 5, 1. We're going to double check just to make sure, do we have anything else? I know you can't see that, but that's 9 over 4, and this is 5 over 2. So those aren't the same. Oh, but look right there. At 7 we have both 4s. So my 2 points of intersection are 5, 1 and 7, 4. Let's go back to the graph. 1, 2, 3, 4, 5, 1. Yeah, okay, I can see it. 5, 1, 6, 7, 4. Alright, so it did hit my functions hit twice. So I have 2 points of intersection. Those are the 2 points that they share in common. So that is graphing quadratics, and you can work on that using your graphing calculator.